Hi everybody. So in today's video, we're going to be going over lesson 6 from unit 3, which is about linearizations and linear approximations. So the basic idea of this lesson is that now that we know how to find lots of different derivatives and we know how to write the equation of a tangent line, we can use the equation of a tangent line to approximate the value of a function. So it's one of the ways that we use tangent lines to make approximations. We have two targets today. The first target is I can write the equation of a tangent line to a function at a given point. So this is something we've done many times already this year. We're writing the equations of tangent lines. And the second target for today is I can use the equation of a tangent line. So now that we've got the equation, I'm going to use it to approximate the value of a function. So to estimate the value of a function or the output value. Here's sort of an introduction to this idea. We know how to evaluate functions, particularly for nice integer values. For example, let's let f of x be x squared. Let's find f of 2. In order to do this, to find f of 2, we would simply substitute the value 2 into the f of x equation, which means we would have f of 2 is equal to, and in this case, it would be 2 squared, which is a very kind of straightforward calculation for us, would just be 4. Now that is fine, but what if I change the problem a little bit and I say, let's use the same function, let f of x equal x squared, find f of 2.1. Now that's almost the same thing as 2. However, the evaluation here, particularly if we wanted to do this problem without a calculator, suddenly becomes something that's less sort of mental math. It's something a little bit more complex for us to do. Now we're going to need to do 2.1 squared, which we would estimate is probably pretty close to the number 4, but in order to get that value exactly, we would need to actually multiply 2.1 times 2.1, which would give us 2 and 1, and then we have to put a 0, and then 4 and 2, which means we get 4, 4, and 1. We need 2 decimal places, and whew, that was a lot more complicated than just sort of 2 times 2. So the idea here is that when we want to estimate these function values for numbers that are not so easy to plug in, so not so nice numbers to evaluate with mental math, we can estimate this value using a tangent line. Since a tangent line stays very close to the graph of a function when it is near the value at which it is tangent, so near the value at which it is tangent, for example, in this case, the 2.1 was close to the value 2. So we're near the value at which we are tangent. We can use tangent lines to estimate function values. So because the tangent line is close to the actual graph, we can use the tangent line to estimate the values on the actual graph or the actual function. This process is called creating a linearization, or using a linear approximation. Now, the word linearization comes from the word linear, meaning line. So in other words, we're using a line to estimate a curve. So we're taking something that's curved, like x squared, and we're using the equation of the tangent line to estimate values of that function. A linear approximation is another way of saying the same thing, which is basically we are approximating the value of a function. In this case, we're approximating the value of 2.1 squared using a tangent line. So there are a couple different ways I want to kind of look at this so that we can see it both with a visual as well as an algebraic representation. So visually, here's what's happening. Let's let f of x equal x squared. So I'm going to graph that. So in green here, I'm going to graph x squared. Now x squared is the kind of basic quadratic function. So it goes through 0, 0, 1, 1, 2, 4. It would go through 3, 9, but my graph doesn't go up that high. And it's going to have this nice kind of U shape to it. Okay. Now, what we're going to do is we're going to write the equation of the line that is tangent to this graph. So we're writing the tangent line to this curve at x equals 2. Then we're going to use the tangent line to approximate what's happening at 2.1. So let's start by, and I'm going to jump over to the algebra for a second, then we'll come back to the visual. We're going to actually write the equation of the tangent line. So to write the equation of the tangent line, we're going to need a point, and we're going to need a slope, which allows us to write the tangent line. Now, my point here is going to be the point 2, comma, because x is 2. And then to get the y value, I'm going to plug that into the original f of x function, which gives me 2, comma 4. To get the slope, I'm going to use the derivative. So the derivative here would be 2x, which means f prime of 2 would be 4. So my slope is 4, which means my tangent line is y minus 4 equals 4 parentheses x minus 2. Now, in this same color, I'm going to graph the tangent line on this graph. So it's going to go through the point 2, comma 4, which is right here. And it's going to have a slope of 4 over 1. So I have the option to go up 4 over 1, which it looks like there's not quite enough room to do that, or I'm going to go down 4, 1, 2, 3, 4, left 1 to graph this line. 4, left 1. And here's my tangent line. Now, what we're going to try to do is estimate or approximate the value of f of 2.1. So for our approximation here, what we're going to do is plug the number 2.1 into the tangent line equation. So for our approximation, the first thing that I'm going to do is I'm going to move the minus 4 to the other side. So my new equation would be 4 over 1, parentheses x minus 2, and then plus 4. So I'm just moving this number to the other side of the equation so that y is by itself. And this equation right here is called your linearization. Now, to estimate f of 2.1, I'm just going to plug the number 2.1 into this equation. So I'm going to have 4 parentheses 2.1 minus 2 plus 4. Now 2.1 minus 2 would be 0.1. 4 times 0.1 is 0.4. And that's going to give me 4.4. So I'm estimating that f of 2.1 is approximately 4.4. And I'm doing that by writing the equation of the tangent line and plugging in a value that's near the point at which we are tangent. If we look at the graph, if we go to 2.1, you can see that these two graphs, the green and the blue, are super close together because this section of the graph is very close to the place where we were tangent. What that means is that this estimated value using the tangent line is going to be very close to what we would get if we actually plugged 2.1 into the original equation. We can confirm this by going back to our original example. If you'll remember, our original example where we actually calculated this out the long way is that we estimated that 2.1 squared was 4.41. Our exact value was 4.41. Our estimation was 4.4. Now, those are very close together. They're within 1/1000th or 100th of a value of each other. It's 1/100th of a value. So this is the estimate for the value that we calculated out the long way. And the reason that this works is because the original graph and the tangent line are very, very close together. So we can use the tangent line to estimate the original function value. All right, let's take a look at some examples here. So in problem number 1, it says the table below gives values of f and its derivative f prime for selected values of x. Write an equation for the line that is tangent to the graph of f at the point where x is 1, and then use this line to approximate the value of f of 1.2. So there are two parts to this problem. The first part to this problem is to write an equation for the line that is tangent to the graph of f at the point where x equals 1. Okay, in order to write the equation of a tangent line, as soon as I see that, I'm going to make a list that I need a point, I need a slope, and then I can write my tangent line. Now my point here is going to be the place where x is 1. On this chart, when x is 1, the f of x, or output value, is -4. My slope would be f prime of 1. And again, I can go to the chart and figure out that that value would be 5, which means my tangent line would be y plus 4 equals 5 parentheses x minus 1. Now, the second part of this question says use this line to approximate the value of f of 1.2. So now what I'm going to do is get the y by itself and then plug in the number 1.2. To get the y by itself, I'm just going to move the plus 4 to the other side. So I'm going to have y equals 5 parentheses x minus 1 minus 4. And now I'm going to plug in the value f of 1.2. So f of 1.2 would be 5 times 1.2 minus 1 minus 4. 1.2 minus 1 would just be 0.2. 0.2 times 5 is 1, and 1 minus 4 would be -3. So I would estimate that f of 1.2 would be approximately -3. Last but not least, it says let f of x equal the square root of x. Write the equation of the line that is tangent to f of x at x equals 1, then use the tangent line to approximate the value of f of 1.2. Again, there are two parts to this problem. Write the equation of the line that is tangent at x equals 1 is part 1. So we have to have a tangent line as part of our answer, and it needs to be clearly labeled that that's the tangent line, because that is part of the question. So the first thing I need is my point, the next thing I need is my slope, and the last thing that I can do is my tangent line. For my point here, my x value is 1, and I'm going to calculate the y value by plugging it into the original function. So the square root of 1 is also 1. To figure out my slope, I need to actually take the derivative. I think it's easier to take the derivative if I rewrite this as x to the 1/2 power. So then the derivative would just be 1/2 x to the -1/2 power. And then I find it easier to substitute in a value if I kind of move that to the denominator. So that would be 1/2 times the square root of x, which is in the denominator because it's a negative exponent, and a 1/2 is really a square root. That means that f prime of 1 would be 1/2 times the square root of 1, which would just be 1/2. So my tangent line would be y minus 1 equals 1/2 times x minus 1. Now the second part of the directions here say use the tangent line to approximate the value of f of 1.2. So the next thing that I'm going to do is an approximation. So I would have my original tangent line. I'm just going to move the -1 over. So it's going to be y equals 1/2 parentheses x minus 1 plus 1. And then I'm going to substitute in the value 1.2. So f of 1.2 would be 1/2 times 1.2 minus 1 plus 1, which means I have 1/2 times 0.2. Half of 0.2 would be 0.1, so my estimation would be 1.1. In other words, the square root of 1.2 is approximately 1.1. And just because I think this is so cool, if I just asked you to find the square root of 1.2, you'd probably tell me that you don't know the answer, and I wouldn't either. But by doing this process, you can confirm on a calculator the square root of 1.2 is about 1.1, which is what we estimated. It's 1.095, so pretty close. All right, thank you guys so much for watching, and I will see you soon for some practice.